Alright, we're looking for one geometric mean between 3 and 108. So, 108 equals 3r to the 3 minus 1, because that's 1, 2, 3 terms. So when I divide both sides by 3, we get 36 equals r squared. When I take the square root, plus or minus 6 equals r. So this answer is plus or minus 18. That was problem number 7. Alright, we're going to sum this geometric series. First we have r equals 3 over 6, which is 1/2. And the sum for this, since it's not infinite, is a sub 1 minus a sub 1 r to the n over 1 minus r. So 6 minus 6 times 1/2 to the 9th divided by 1 minus 1/2. Generally, I just do the numerator. And we get 1533 over 256 divided by 1 minus 1/2 is 1/2. And we're going to wind up with 1533 divided by 128. If you decide to get this as a decimal, it turned out to be around 11.98. Alright, in number 8 we want to sum a geometric series. So because this one has r equals 2 over 6, which is 1/3, which is in between -1 and 1, we can do it. We got a sub 1 over 1 minus r is the formula. 6 divided by 1 minus 1/3 turns out to be 9. Alright, for this problem, we're doing limits. First thing we want to do is check to see where there's the highest exponent. So since the highest exponent of 3 is on top over here, no matter what, we're going to say that there is no limit to that problem. In part B here, we have squareds on top, squared on the bottom. This one doesn't matter. So my answer is going to be 4 over -2, which is -2. That was number 9. So I did these out of order. That one that we had back here was number 10, the sum of the infinite. But you're all intelligent enough to switch 9 and 10. When we have a summation problem like this one, we plug in 3 first, so we got 3 squared plus 1, which is 10. 4 squared plus 1, which is 17. 5 squared plus 1, which is 26. 6 squared plus 1, which is 37. And we add them all together. And we get the answer of 90. Alright, this one has our 1 to infinity, so we do look at the first one. So we got 5 times 1/2, which is 5 halves. We have 5 times 1/2 squared, which is 5/4. And the next one we have 5 times 1/2 to the 3rd, which is 5/8. And we're going to keep going and going and going. So here's our geometric series. So when we do 5/4 divided by 5 halves, that turns out to be 1/2. We use the formula a sub 1 over 1 minus r. So we got 5 halves divided by 1 minus 1/2. And when we do that, we get an answer of 5. Alright, so to do this problem, x plus 2y to the 5th, I'm going to do my Pascal's triangle. And so there's my fifth line right here. Those are the numbers I'm going to be using. So I got 1, x to the fifth, plus the next number is 5, x to the fourth, 2y to the first. Then we got 10, x to the third, 2y to the second. Then we got another 10, x squared, 2y to the third, another 5, an x, 2y to the fourth, and then we got a 1 and 2y to the fifth. 1x to the fifth stays the same. 5 times 2 is 10. X to the fourth, 1y. 10 times 2 squared is 40. X to the third, y to the second. 10 times 2 cubed is 80. X squared, y to the third. 5 times 2 to the fourth is 80. 1x, 4 y's. And then 2 to the fifth is 32. Y to the fifth. Okay, as always, if you have questions, please ask, email, talk to me in class. That's it for chapter 12.